Hello everyone, this is Harshita. So today I'm here to explain the digital voltmeter using Arduino. So this is my circuit. I have written my entire code in Arduino IDE app. Now I'm going to simulate my circuit using online website tinkercad.com. I'll start with the components that I have used here. I have used an Arduino Uno board, a breadboard, and for my power supply, I have used this component. And to display various voltage reading values, I have used an LCD 16 into 2, that means 16 columns and 2 rows. So these are the components that I have used. Other than that, I have used a 220 ohms resistor and 1 mega ohms resistor and 10 kilo ohms resistor. So I'll start with the connections of LCD. I have connected the LCD DB45672 5432 pins of Arduino Uno board. I have connected RS and enable pins to 12th and 11th of Arduino Uno board respectively. Then I have grounded G and D, VO and RW to the negative terminal of the breadboard, and I have connected one LED to the negative terminal of the breadboard and one LED to one terminal of my 220 ohms resistor, and the other terminal I have grounded it with the negative terminal of the breadboard. So this ends our LCD connections. Then I am going to give connections to my voltage divider circuit. Here I have taken two resistors and built a voltage divider circuit. I have constructed the circuit to maximize my voltage readings range. So whenever I am using my Arduino Uno board, my power supply will be of 5 volts. So when I am constructing a digital voltmeter, I need more voltages to be read. To maximize the ranges of the voltages, I have constructed this voltage divider circuit. Here I am considering 1 resistor as 1 mega ohms and the other resistor as 10 kilo ohms. So I'll consider my greater value of R1 and the other resistor will be my R2. So we can change the values based upon the readings that we want. And I'm connecting my power supply terminal to one end of the 1 mega ohms resistor, and I'm grounding the negative terminal of the power supply, and the junction of both the resistors I'm connecting it to the analog pin A0 of the Arduino Uno board, where I'm going to read my analog voltage value and then display it on my LCD. So the other end of the 10 kilo ohm resistor, I'm grounding it. Later, here we need to remember that the negative terminal of the breadboard should be connected to the ground of the Arduino Uno board, and the positive terminal of the breadboard should be connected to the plus 5 volts supply of the Arduino Uno board. So this ends our connection. I already copied my code here. So hash include liquid crystal.h. As I'm using LCD display, I will be using this library. Later, I'm going to initialize the pins that I'm connecting to LCD on the Arduino board. So I'm connecting 12, 11, 5, 4, 3, 2 pins. So I'm initializing them. Later, I'm declaring all the variables of float data type, and input voltage I'm initializing with 0.0, temperature 0.0, and as I already told you, my R1 is 1 mega ohms and R2 is 10 kilo ohms. Now void setup serial begin 9600 baud rate. I am using this for displaying the values of voltages on serial monitor. You can completely avoid it and only use LCD for displaying, but I have also declared it. So LCD begin 16, 2, LCD print digital voltage. First I'm printing digital voltmeter on my LCD to know that it's a basic voltage reader. So later I'm using float for analog value. I'm storing analog read A0 in analog value. So whatever voltage I'm reading at analog pin A0, I am storing it in the variable analog value. Then I'm declaring an extra variable temp where I will be calculating my input voltage. So whatever the value I'm reading it from analog pin, and I'm multiplying it with 5 because here my supply will be 5 volts. So I'm multiplying it with 5 and dividing it with 1024, which is 2 power 10. Here we have 10 divisions of current. So I'm using 2 power 10 1024. Later, my final input voltage will be the extra variable temp that I have calculated above divided by R2 by R2 plus R1. This I am doing it because I have created an extra voltage divider circuit. So now calculation part is done. Now we have to display that on our LCD screen. If my input is less than 0.1, which means very nearly equal to 0, I will display my input voltage is equal to 0. So for that I have created this if loop. If not, if it is greater than or equal to 0.1, I am going to print on my serial monitor that V is equal to. Later, I'll print input voltage. This value of this variable will be assigned to V is equal to. On the LCD display, I am setting my cursor to 0, 1. That means the second row, and then I'm displaying voltage is equal to. Then LCD print input voltage. Whatever value is assigned to this variable input voltage will be displayed on my LCD, and I'm giving a delay of 1000 nanoseconds. So this is the code I have written. Now I'm going to start simulation. So whenever I start my simulation, as I have given digital voltmeter in the first line and the second line voltage is equal to, as you can see here, the power supply voltage is 8.80 volts. Here 8.88. There is a slight error that is occurred due to this voltage divider circuit and the resistors that we are using. Now I'll change the value to 3.60 volts and here 3.45. 14.8 and here 14.79. So this is how we can display the voltages and this is a digital voltmeter. Thank you.